Hey everyone, my name is Marc Bates. I'm a metabolic health coach, and today's topic is the hidden truth about nutrient absorption. And this is a very interesting topic. Okay, that colorful plate of vegetables might look nutritious, but your body has a different opinion. What matters isn't what you eat, it's what you absorb. The advice to eat the rainbow, right, seems logical on the surface. More variety should mean more nutrients, but this ignores a crucial factor: bioavailability. Bioavailability, the proportion of a nutrient your body can absorb and use, changes everything about nutrition. Regarding bioavailability, animal foods consistently outperform plant foods by significant margins. The bioavailability gap. When nutritional content is listed on food labels or in nutrition databases, it shows what's in the food, not what your body gets from it. This distinction matters enormously. Take vitamin A as an example. Plants contain beta-carotene, a precursor that your body must convert to the active form of vitamin A, retinol. This conversion is remarkably inefficient. Studies show that absorption of beta-carotene from plant sources ranges from only 5% to maybe 65%, while we typically absorb 75 to 100% of preformed vitamin A, retinol, from animal sources. That's not a slight difference. It's a nutritional chasm. Even worse, approximately 45% of the population has a genetic variation that reduces their ability to convert beta-carotene to vitamin A by up to 70%. Plant sources of vitamin A are nutritionally inadequate for these individuals. This pattern repeats across numerous nutrients. The iron in meat, heme iron, is absorbed in 15 to 35% range, while non-heme iron in plants is absorbed in just in the 2 to 20% range. The protein in eggs is nearly 100% digestible, while many plant proteins hover around the 60 to 80% range. Then you have the anti-nutrient problem. Plants don't want to be eaten. Unlike animals, they can't escape predators, so they've developed chemical defenses, compounds that interfere with nutrient absorption. These anti-nutrients include oxalates, phytates, lectins, and tannins. Their effects are substantial. Research shows that oxalates reduce spinach's calcium bioavailability to just 5%. Even though spinach contains significant calcium on paper, phytates in grains and legumes bind to minerals like zinc, iron, and magnesium, preventing their absorption. The implications are profound. A diet that looks nutritionally complete on paper may leave you functionally deficient if it relies heavily on plant foods. Exclusive nutrients in animal foods. Okay. Beyond bioavailability issues, some essential nutrients just don't exist in meaningful amounts in plant foods. Animal-sourced foods are the most exclusive natural sources of vitamin B12, 65% bioavailable, and preformed vitamin A, retinol, as we've discussed, is 74% bioavailable. They also contain highly bioavailable forms of numerous B vitamins. Vitamin B12 deficiency is a serious concern, particularly in populations that consume few animal products. This vitamin is crucial for neurological function, DNA synthesis, and blood cell formation. Other compounds found predominantly or exclusively in animal foods include creatine, which supports brain function and physical performance. Vegetarians typically have lower creatine levels than omnivores. Carnosine is an antioxidant that helps prevent cellular damage. Levels in vegetarians are typically lower than in meat eaters. DHA is an active form of omega-3 fatty acids, critical for brain development and function. The plant form ALA converts to DHA at rates below 5% in most people. Heme iron is essential for oxygen transport and energy production. Non-heme iron from plants is poorly absorbed in comparison. Okay, real quick. Do the channel a big favor if you would like, share, and subscribe to us. Thank you so much. Okay, the nose to tail advantage. A well-formulated carnivore diet includes more than muscle meat. It also contains organ meats, bone marrow, and sometimes dairy or eggs, a practice often called nose to tail eating. This approach provides an exceptionally complete nutrient profile. The liver alone is one of the most nutrient-dense foods on the planet, rich in vitamin A, B vitamins, iron, copper, and folate. Just 30 grams of liver daily exceeds the optimal intake levels for several essential nutrients. Bone marrow provides vitamin K2, collagen, and glycine, and the heart is an excellent source of CQ10. Even the concern about vitamin C, often cited as a reason carnivore diets must be deficient, overlooks that fresh meat contains small but sufficient amounts of vitamin C, and by limiting carbohydrates, your cells are not competing with carbs, which use the same GLUT4 pathway, for absorption. Historically, Arctic explorers and indigenous peoples thrived on all meat diets without developing scurvy. The nutrient density calculation. When we factor in bioavailability, animal foods are far more nutrient dense than plant foods. Consider this comparison. A 100-gram serving of beef liver provides more bioavailable vitamin A than would be absorbed from several pounds of carrots. Despite similar zinc content on paper, the zinc in a small portion of oysters is more bioavailable than what you'd absorb from a large bowl of pumpkin seeds. The protein in a chicken breast is more complete and digestible than what you'd get from such larger portion of quinoa. This isn't just about quantity, it's about efficiency. Animal foods deliver more nutrition with less volume, less digestive strain, and fewer anti-nutrients. Understanding this can empower you to make informed dietary choices. Metabolic advantages. Beyond pure nutrition, carnivore diets offer metabolic advantages that further enhance health. By eliminating carbohydrates, they stabilize blood sugar and insulin levels, which can improve nutrient partitioning and utilization. This metabolic advantage is intriguing and enlightening about the potential health benefits of a carnivore diet. Ketones, produced during carbohydrate restriction, have been shown to enhance mitochondrial function and reduce oxidative stress. This creates an internal environment where nutrients can be used more effectively. The absence of plant toxins also reduces inflammatory burden, potentially improving gut barrier function and nutrient absorption. Many people report improved digestion and reduced bloating when switching to carnivore, signs that their digestive systems are now working more effectively and efficiently. Okay, common misconceptions. Despite the evidence, several misconceptions persist about carnivore diets and nutrition. Correcting these misconceptions can reassure and confidently increase one's understanding of nutrition. Misconception 1. You need fiber for gut health. Fiber is often touted as essential for gut health, but many carnivore dieters report improved digestion function without it. Some research suggests that fiber irritates the gut in specific individuals. Okay? If you can't digest it, why are you eating it? Misconception 2. You need plants for antioxidants. Okay, while plants do contain antioxidants, animal food contains others like glutathione, CoQ10, and carnosine. Moreover, a low-carb diet naturally produces fewer free radicals, reducing the need for dietary antioxidants. Misconception number 3. Carnivore diets lack micronutrients. A well-formulated carnivore diet that includes organ meats provides all essential micronutrients in highly bioavailable forms, much more so than you'll get from plant foods. And misconception number 4. You need carbohydrates for energy. The body can efficiently use fat and ketones for energy, often providing more stable energy levels than carbohydrate metabolism, and also it typically is a cleaner form of energy than making ATP from carbohydrates. Okay, and a final misconception. When I say carnivore, people go, well, I can't eat nothing but meat. A carnivore diet is defined as eating 70% or more of your energy intake. And I don't like using carbohydrates because that's not an appropriate, correct measure of energy, but we'll just for the moment, most people are comfortable with carbohydrate or with calories. That means eating 70% of your calories or more as part of your caloric intake. Okay? It doesn't mean 100%. Remember, the idea of a carnivore diet is go back to what our bodies were designed for, and the human body was designed for eating primarily animal fats and proteins, but you're also adapted to eating some additional berries, fruits, tubers, and stuff that we would find in the wild. The problem is that we don't make them part of our everyday diet. We don't eat them in large amounts. They're just there when we don't have meat to eat. Okay? So keep that in mind. You enjoy, if you enjoy some berries, you can have berries. Not a lot. And try to eat them separate from eating your meat and fat, as you would if you're out in the wild, right? Okay. Hope that helps on that one. Okay, the evolutionary perspective. Okay, humans evolved as omnivores with a strong preference for animal foods, i.e., the vast majority of the food they would eat is from animal flesh, animal fat and protein. Okay, archaeological evidence suggests that our ancestors prioritized hunting over gathering whenever possible. That makes sense. Brain development in human evolution correlates strongly with increased meat consumption. The energy-dense, nutrient-rich nature of animal foods likely enabled the development of our large, metabolically expensive brains. Our digestive systems reflect this evolutionary history. Compared to herbivores, humans have smaller colons, larger intestines, and stomach acidity levels that are similar to scavengers and predators. All adaptations that favor animal food digestion. Beyond theory, real-world results. The ultimate test of any dietary approach is how it affects real people. A survey of over 2,000 adults following a carnivore diet reported remarkable improvements in various health conditions, including obesity, diabetes, gastrointestinal issues, and skin problems. All problems that started to plague the human race when we switched from being a hunter-gatherer and raising ruminant animals to being primarily an agricultural society. Okay? Particularly notable were the results of those with diabetes who reported significant reductions in medication needs and improvements in glycemic control. These outcomes suggest that the diet is nutritionally complete. The carnivore diet is nutritionally complete and potentially therapeutic for specific conditions. So let's rethink nutritional completeness. The evidence challenges us to reconsider what constitutes a complete diet. Nutritional completeness isn't about checking boxes for vitamins and minerals on paper. It's about providing what the body, the nutrients that it needs. By this more meaningful standard, a well-formulated carnivore diet may be one of the most nutritionally complete approaches. It provides highly bioavailable forms of all essential nutrients without interfering with anti-nutrients. This doesn't mean everyone should adopt a carnivore diet. Right? Individual variation in genetics, health status, and goals means that dietary needs will differ. But it does mean we should question the conventional wisdom that plant foods are necessary for complete nutrition. What matters isn't the theoretical nutrient content of your diet, but what your body can extract and use from it. Regarding nutrient extraction and utilization, animal foods consistently outperform plant foods. Okay? Bottom line. The rainbow on your plate might look impressive, but your body cares more about substance than appearance. Animal foods deliver that substance in the most bioavailable, complete form possible. So, thank you for watching. If you have any comments, please leave them appropriately. We'll answer questions. And if you have any items that you'd like us to cover in future episodes, please let us know. We'll try to get them in as soon as possible. Thank you.